Alright, well, we're down to the legs, so this one's a bit different because the material's slightly thicker. It's 3mm, so the only thing we really have to think about is just changing the cutting depth when we run the toolpath, and I'll show you how to do that, of course. Okay, I just went off camera and just did a confirmation of the thickness of that material. It's definitely 3.1mm, so what I'll do is I'm going to make a passing depth cut of up to 3.25. So alright, we'll select all of the components and just get rid of the outside periphery, and we'll do a profiling cut on the inside again. So cut depth 3.25mm, so I definitely know I'm going through the material and leaving a good nice clean cut through the bottom. It's a 1.5mm bit on the inside, and we'll cut that. Okay, just acknowledge the fact that my material hasn't changed, so we'll just reset the preview here because we don't want all that. It looks good, so the holes and the motor outputs. Okay, and then we need to do the outside. So we'll just select all of that, close that view, and outside 3.25 still, 1.5mm bit. What I'm actually going to do, I'm going to change the cut depth of this to be 1.5, so it'll do it in 2 passes. Actually, I'm going to do it in 3 passes. So if I set it to 1mm, it'll be a lot better. It's going to be, yep, I'm going to do that. So calculate that, and we just need to go back to this profile, edit, make the pass depth on this 1mm as well, so we get the full number of profiles to cut it. Okay, so let's just make sure that's 1mm, and for the last profile on the outside, just make sure that's 1mm. Cool, so it'll do it in 3 passes, 1mm, 2mm, and then the 2.25. I'm happy with that. Alright, we'll select these 2 and save the toolpath. So this will be, just grab this as a reference. Legs 1.5 burr, and it's 3.1mm plate. Save that. Excellent. I'll just transfer this over to the CNC machine, set up the material, and we'll get cutting. Okay, let's pop one out before the battery on the unit finishes up. And there we go, one set of legs. Very happy with that. Give them a clean up and I think they'll be good to go. So I've made a small jig which fits in the lathe, and that'll produce reasonably consistent results from the perspective of having the standoffs consistently be 14mm in distance. So the gap between the cutter edge and the face of the awl thread is, I've just jigged it to 14mm, and I've got a couple of captive nuts there just to hold it in place. The process is quite simple. Open the jaws, line up the awl thread, push the material up against it so it's virtually zeroed. Come forward and we just part it off. So I'll show a couple of those as one process. There we go. Simple as that to churn out a number of those. So I'm just going to go ahead and make up, I don't know, 10 to 15 of these, probably 15, just so I've got a couple of spares, and I'll marry up the ones that are closely matched in length. And we'll just check it, and we should see that it's 1406. So you know what, that's pretty good to me. So the next component that I need to make in the way of standoffs is the spaces that we're going to use for the top plate. So I've got a reading here of 38, which is close to virtually 1.5 inches. So if I put it there, we're right on 1.5 inches, so I'll go ahead and make some standoffs for that length. So once again, what I'll do is I'll open this up so that it's 1.5 inches between the cutter and the actual awl thread here. So that'll take a little bit of adjustment, but yeah, I'll come back and show you one of those. Measured the offset as indicated before, and now it's just a matter of running through the processes again to produce a component that's reasonably accurate. Just trying to get off a little knob that was there. Push up the material. And machine it, and let's measure it. That's not bad, that's 38, 37. I'm pretty happy with that, and I was after 38, 38. So I'll go off and make a whole heap of those as well, and then we'll go through and do the next part of the process, which is to drill and tap it. I've gone ahead and removed the jig that I had used to create the offsets, and you know, we've got the small little buttons that need the post process. So basically we need to center drill these, drill them with a 2.5mm, and then we need to tap it. I've already got one in the chuck. It's centered up because it's a 3-jaw chuck, self-centering, and what I'll do is I'll use a centering bit, and then I'll change it over to a drill bit and run through that 2-step process. So the last thing we need to do is basically run a 3mm tap through here so that we've got the thread for the screws to go in later, and I do that with a drill and a tap. And that completes the operation for the first standoff. Of course, I'll go ahead and just clean up all the burrs and so forth that are on here. Then it's just a matter of doing all the small ones and all the long ones. So I just wanted to mention with the longer ones it's a two-part process, because of course I can't drill all the way through and get all the way with the tap. So basically you've got to do it in a two-stage, which is you know, drill and tap from one side and then turn it around and drill and tap from the other. I'll just show you one just for the sake of showing it. And that's it. It's one of the units, drill and tap for 3mm on either side. Once again I'll clean it up and, you know, it should be a lot better. It's a bit hard to see this way. So after spending a fair bit of time, all the components are done. So we've got our 1.5 inch 38.4 or our 14mm standoffs, all drilled and tapped, ready to rock and roll. So I pre-installed the standoffs on the sides. There's 2 that go into the front and another 4 down the side there. They just butt up against the rail, and with 6mm standoffs you see that that's 6mm diameter. You see that it doesn't interfere with the side rails, which is really good. The original concept of the quad was to have swinging arms, so we have one of the arms here. It's got a motor pre-mounted, and I just ran some shrink wrap over the front of the arm so that, you know, we can keep the wires a bit neater and they don't flop around in the air. And like I said, the concept was that the arms could actually swing forward, or in this case pull the pin out on the rear, and they could swing back to a degree, and you could do the same with the back. However, I really don't want that ability. It's a small quad, you know. By the time we add a couple of other arms, it's, you know, 360 between diagonals isn't motor to motor, that is, you know, isn't huge. So I'm going to fix these, and to allow me to fix them, I went ahead and I've machined up some bungs on the side. So this was just some seedle that I had. I cut it to length, so it was 14mm, of course, minus the thickness of the arm that's going to go on there to give me the total dimension. And so these have been machined down to 10.9mm. I then went and drilled and tapped each one for a 3mm bolt, and I found a 3mm bolt that goes all the way through and pops out the bottom, so I can actually run no-lock little nut on it. Bit hard to see there, but no-lock nut. So let's go ahead, quickly do one of these, and then I'll do the others and show you sort of the result of what it looks like. It's a bit of a pain because I threaded the whole lot, but that's life. Threaded a whole lot of this on there. So just do it up so it goes all the way through. Same with the second one. Should give it good stability because I wanted a large surface area to take the load of the legs. I don't want them vibrating, and I know that we've got vibration dampeners also going to be positioned across the frame, so it's, you know, a clean and a dirty section. I still want to minimise any of the problems that we might experience. So the leg just slides straight on, and then it's just a matter of jigging the base plate up, which is a bit more effort because of the fact I've got to get it in the grooves. Alright, so I've got the front ones in, and let's swing this out of the way, and I'm quite happy with that. So if we look at, you know, the spacings, they marry up pretty good. So we've got good purchase all the way through on the two front lugs, and we've got the bolts that go all the way through, and I can put a nut onto those. Before I go ahead and install the ESCs, I just wanted to give you a bit of a look at what I'm using. So these are the Hobby King 30 amp ESCs, and what I did was I went ahead and I've actually flashed these ESCs. I cut a small component of the heat shrink out of there, and I've got a programmer chip which I place onto the chip, and I flash it with a SimonK firmware. So I went ahead it ages ago and I've actually flashed these. I know that the code that I use on these works beautifully with the Sunnysky, so I'm not going to go out and try to do an upgrade to them. You know, all it really needs is 3 lugs to be connected onto the ends, 3 mils, and then I'll connect these ends to this power distribution board. So this is the power distribution board that, you know, it came from somewhere. I think I bought some stuff and they sent it in as part of, you know, the stuff that I got as a freebie, and it's just a matter of sticking the wires through and then soldering the connectors on. So it's as simple as that. I just wanted to show you this and explain a little bit of what I'm using in the way of the ESCs, and I find that the 30 amps is more than enough for the current draw that, you know, and especially the way that I fly. So I try to use these power distribution boards. I really like them. You know, they're handy. They've got lots of connections. They're all interlinked. But I came across an issue where, with the power distribution board, you know, being quite large, and trying to hook up all of these ESCs, there just wasn't enough room. So I had to think about a different alternative. I mean, I even wrote it. I even did a video sequence on the power distribution board and how I was going to go about it. So I've changed my mind, and I'm borrowing off some friends of mine who built the DRQ 250, and they came up with this really ingenious power distribution board, and it ultimately is a copper plate. Yeah, I should give you a bit of a show there. It's a copper plate that's been split in two, and what you do is you've got a positive and a negative rail, and you just put your battery terminal leads off of this for the plus and minus, and then you just hook all your you hook all your ESCs straight to those as well, and solder them all up. Part of the trick really when you're doing this soldering is to ensure you've got a good soldering iron as well, because you want to have a lot of heat really quickly applied to the plate so you don't delaminate it. And by using this power distribution, what I can do is I can just add an ESC like that. So, you know, I'll have one, as I said, one leg going to one of the plates and the other leg going to the other plate, something like that, and it'll give me good reliable working electronics. So as much as I really wanted to go with those power distribution, sometimes things just don't pan out the way you want it to, and you've really got to think about doing an alternative. For the purpose of doing the soldering, I'm going to be using this big iron. It's got a nice big tip on it. I'll give that tip a bit of a clean. And I'm going to solder over the copper plate to give myself a nice bead to adhere to. And I think I'll probably even use some flux on this so that I get a nice layer across it. And then what I'll do is I'll place it back into the frame with those plastic lugs, which are probably going to be expendable because with the heating that I'm going to do, it's probably going to melt them, and I'll just replace them later. And yeah, start soldering up the ESCs. The iron's now hot, so I'll just add some flux paste just so that it'll hopefully spread a bit more evenly. Don't need too much of this. A little goes a long way. Okay, the iron's nice and hot. You can see it. I've gone and cleaned it, and we'll just tin up the plate a bit. One side done. Add some more on the other side. Cool, that'll do for now. Alright, let's throw this in. I won't bolt it down, it's going to defeat the purpose. Make life nice and simple. We'll start with this side as being the positive. Alright, that wire's already pre-tinned. Let's do it so you might be able to see what's going on. There we go, we've got good adhesion. So don't forget, that's the positive rail, that's now going to be your negative rail. Okay, simple as that. That's one ESC done. Second ESC, I just went ahead and pre-tinned the red and black wires. Now we can put that one in upside down. All right. Good, that's soldered in. Fits in nice. Watch what I do. Two down, two to go. Let's try the next ESC. This time let's try to not burn the cables. That's good, I've got adhesion here, so what I'm going to do is I'm going to go back and I'm going to overfill these with more solder so that, you know, it's got more to bite to. Because at this stage, got to be a little bit worried that it might come off. It looks like a slightly dry joint. Lucky last unit. I'll just put her in a position. Okay. Somewhere up around here. Simple. And the black one. I think I decided just put the black around here somewhere. Okay. There we go. So we've got the 4 ESCs all hooked in. So we've got positive rail, negative rail, and lastly what I'll need to do is work out where I'm going to put the lead for my battery. So yeah, that's my next decision. I'll have a bit of a think about that, and then I'll go over the top and I'll just add some more solder into these areas so that, you know, I know it's got a nice permanent connection, and it's just a matter of filling it with a bit of that solder paste. Time to make the connector. So I might swing this around this way, only because I'm right-handed. Okay, just add in some tin to the gold connector. So look there, we've got some tin on each side. Okay. Quick word of warning, you need, if you're using the XT60s, you need the female to take the connection out of the battery. The amount of times I've soldered the male instead of the female for these connectors, and you will kick yourself. But a simple jig makes it easier to do all the work, and it's just a matter of now soldering up that red connection into the connector itself, and then we can add some sheathing to finish that up. There we go. That's why a nice hot iron works really well. So connections made very quickly without applying too much heat to the actual unit itself. There we go, there's the second one done. So I've got some tube to go onto the unit. If it's still warm, it works in your favour because it will actually allow you to shrink it in while you're pushing it. There we go. Black side's done. Now the red side. There we go, like I bought one. Nice connection all the way in. It's not going anywhere in a hurry either. And I've made the wire lengths a bit longer on the red so I can get that extra reach that I'm going to need for the other side.